Yeah. So they become, they're released as CO2. So let's go back. So they're being released as a CO2. So we are saying that there is some CO2 being released. That's what's happening to some of the carbon molecules. And then I want to see if you guys remember what ADP stands for. So we have ATP as 3 phosphates. And then we have ADP. T stands for tri, 3. D stands for di. So that's 2 phosphates. And this ADP needs to be replenished, means another phosphate needs to be added. And that happens in the Krebs cycle. That's how you get 2 ATP. This is how complicated this is. This is the steps for Krebs cycle. I'm not asking you to memorize this. When I was in university, I had to memorize all the steps. But this is just intro bio. Again, I'm not going to ask you to know all the steps, just know the numbers. I expect you guys to know the numbers, what goes in and what comes out. So we said acetyl-CoA goes in, and we're just talking about one pyruvate here. We're not talking about the second one yet, but this happens twice for 2 pyruvates. Acetyl-CoA goes in. First thing you notice happens is citric acid. So that's where the name comes from. Again, I'm not asking you to memorize these. I'm just trying to show you what's coming out. So you make another NADH, another one here, another one here. So you get 3 NADH from if this spins once. If this happens twice, you're gonna get 6 NADHs. And it's gonna happen twice because you have 2 pyruvate. And you get another FADH. So you get 1 FADH here. And you get 1 ATP. Now let's see if you guys can maybe help me write down the numbers. So acetyl-CoA combines with a 4-carbon molecule known as citrate, and then it goes through the cycle. And also the whole thing, so some of the molecules get recycled, and you don't have to know the name, into oxaloacetate, and then the cycle just keeps running. So citrate is rearranged, oxidized, and in the end, it's gonna give you 3 NADH, and then 1 FADH, and 1 ATP per turn. So we said it happens twice. So let's see if you guys can maybe help me with the numbers here. So how many NADH is gonna come out of Krebs cycle total for 1 glucose molecule? Six. Jacqueline said 6. So you get 3 NADH per cycle, per turn, but it happens twice because you have 2 pyruvates. So you're gonna get 6. What about FADH? 2. Scott said 2. So that, again, 1 per cycle. It happens twice. So you're going to get 2. How many ATP? It says 1 per turn. So 2 ATP total. So that's the result for a Krebs cycle. Now maybe try to think back and see what we got for glycolysis. What did we get for glycolysis? Did we get any NADH? 2. Yes, we got 2 NADH. What about ATP? Net ATP. 2. That's what we got from glycolysis. We had an intermediate step. Intermediate step was the acetyl-CoA. So let me just say acetyl-CoA. What did you get out of this? Did you get anything that was useful? So that's when pyruvate is being modified and it turns into 2-carbon molecule. CO2 leaves as a waste product, and it also releases NADH because it happens twice. So 1 NADH times 2, that gives you 2 NADHs for this as well. How many total NADH you have so far? How many total NADHs you have so far after the Krebs cycle? Scott said 6. No, total. Glycolysis, acetyl-CoA, Krebs cycle. Let's count it together. You got 2 here from glycolysis. You got 2 more from acetyl-CoA, 4. You got 6 from total of Krebs cycle. It happened twice. So how many that makes? 10. You get 10 NADH, and you get 2 FADH. All those are going to go to electron transport chain. All that is going to go to electron transport chain and make an ATP. If you think about ATP, you don't have much yet. You only have 4 ATP, 2 from glycolysis, 2 from Krebs cycle. Most of the ATP is going to come out of electron transport chain. This is just to tell you the whole cycle happens again. It gets recycled and recreated. So that it's a cycle. That's why we have the cycle in the name. Keep in mind that 2 acetyl-CoA molecules are produced from each glucose because it's broken down into 2 pyruvates. That's the total. So far, aerobic respiration of 1 glucose molecule has yielded only 4 ATP, only 4, not much. 2 from glycolysis, net, 2 from Krebs cycle. But we did get a lot of NADHs. We got 10 NADHs, and we got 2 FADHs, FADH2. Those are electron carriers, but we only got 4 ATP. But 10 NADH molecules have been produced, as well as 2 FADH. What's going to happen to these electron carrier molecules? What's going to happen to the NADH and FADH2? Where are they going to go? Electron transport chain. So they start going to electron transport chain.